Hello everyone, welcome to Statistics Insight. Today's video is the trailing video of the previous video. So we shall consider some more problems of IIT-JAM 2022. So let's begin. Now in this question, it is told that let x be the random variable having the probability density function as given, where a and b are real constants, and we are given that probability of x greater than or equals to 2 is 2 by 3. So we are asked to find the expected value of x. So let's proceed. How we do? We are given that we know that the area of the PDF is equals to 1, ax square plus b dx is equals to 1. What we get? Ax cube by 3 plus bx. Okay, 3 and 0, and it is equals to 1. So substitute the upper limit and the lower limit here. What we get? 9a plus twice b, okay, is equals to 1. Let's consider it to be the number 1 equation, and we are given probability of x greater than or equals to 2 is equals to 2 by 3. Let's compute the probability. 2, and the upper limit of x is 3, right? Then the PDF of x. That is equals to 2 by 3. So let's compute the integral. Ax cube by 3 plus bx within the range of 3 to 2. 2 by 3. So let's substitute the values of upper limit and the lower limit. What we get? 9a plus thrice b minus 8 by 3a minus twice b, that equals to 2 by 3. Now let's take the LCM for a, for this part and this one. 3, 27a minus 8a, right, plus b is equals to 2 by 3. This is 19a by 3 plus b is equals to 2 by 3. Let's consider it to be equation number 2. Solving 1 and 2, we get a is equals to 1 by 10 and b is equals to 1 by 30. Now we are required to find the expected value of x. Therefore, expected value of x is 0 to 3 x and f of x. What will be f of x after substituting the computed value? X square by 10 plus 1 by 30 dx. So what we get here, x to the power 4 by 10 into 4, 40 plus x square by 2 into 30. So 2 into 30 is 60. 30 is 60. Okay. 3 and 0. After computing, 3 to the power 4 by 40 plus 3 square by 60 minus 0 plus 0. What we get? Compute this one, we will get 2.025 plus 0.15. The final result is 2.175. So this is the answer. Let's move on to the next question. Now here we are given the order statistics and the continuous distribution with probability density function is given by f of x. Now we are required to find the expected value of any order statistic for which the expected value is finite. Now we are required to find expectation of xr where r ranges from 1 to 5. Now we have to look into the expected value which is finite. Okay, for that we know the Rth order, the PDF of the Rth order statistics is 1 by beta r n minus r plus 1 f to the power r minus 1 of x 1 minus f of x to the power n minus r and f of x. And now we are required to find this fx. First, let's find it. F of x. The range would be from 1 to x. Okay, then 1 by x square dx. What we will get? We will get 1 minus 1 by x as the CDF of x. Okay, now we can write the PDF. F of xr of x 1 by beta r n minus r plus 1 1 minus 1 by x to the power r minus 1, and here it will be 1 by x to the power n minus r. And what is fx? 1 by x square. Now for expectation of xr. Expectation of xr, x and the PDF of Rth order statistic. One by beta r n minus r plus 1 1 minus 1 by x to the power r minus 1, 1 by x to the power n minus r, and 1 by x square dx. Okay, let's reduce this term. What we will get, 1 by beta r. What is n here? The n is 5. Okay, 5 plus 1, 6, and 6 minus r. 6 minus r. Okay, then 1 minus 1 by x to the power r minus 1. Then it will be the power of x. Here it is 1, here it is 2, and here it is n minus r. So summing up all these things, we will get 6 minus r dx. Now the next process is we will compute the expectation of x1, compute it, expectation of x2, compute it, and find it if it is finite or infinite, x3, expectation of x4, expectation of x5. Compute this and find it where it is finite, then see where it is finite for r equal to 1, 2, 3, 4, 5. Okay, let me say expectation of x5 will be infinite. So it will be tedious to calculate all the expectations, so I have told you the answer. So expectation of x5 will be infinite, so the possible value of r will be 1, 2, 3, and 4. Summing of all these r, we will get 4, 5, 6, 7, 8, 9, 10. So the required answer is 10. Fine, let's move on to the next question. This one. Okay, we are given that xy be a discrete random variable, then we have to look which option among these are correct. This is a multiple select question. Okay, so let's see. We are given that x and y are independent. As I told in the earlier video, if x and y are independent, then the Borel measurable functions of x and y, that is f of x and g of y, will also be independent. See, here it is a function of x, this is also function of x, so these two will also be independent. So option 1 is correct. For number B, it is told that if the correlation coefficient between x and y is 1, what does it mean? The correlation coefficient is 1, that means positive 1. This means there is a perfect linear relationship between x and y. So in probabilistic term, what we can write, the relationship, what we can write about the relationship of x and y. Probability that y is equals to ax plus b is 1. This means we are absolutely sure that there is a linear relationship. So option B is correct. For number C, we are given that if x and y are independent and expectation of xy whole square is equals to 0, then probability of x equal to 0 is equal to 1, or probability that y will take 0 is equal to 1. We will check this one. What we are given? We were given that the expected value of expectation of xy square is equals to 0. This will imply expectation of x square y square is equals to 0. Let's write here. Since x and y is independent, so x square y square will also be independent. Expectation of x square, expectation of y square, and this is equals to 0. We are given. Now for expectation of x square, since it is a discrete x square, probability of x is equals to x. Okay, this is sum over x and this is sum over y. Y square, probability of y is equals to y equal to 0. Okay, now for this whole term to be equal to 0, either x has to be equal to 0 or y has to be 0, right? Only then we will get the whole term as 0. So either x has to be 0 or y has to be 0. Has to be 0 almost, sorry, or y has to be 0 almost surely. Right, probability y equal to 0 is equals to 1, or probability of x equals to 0 equal to 1. So option C is also correct. Now comes number D. Here it is given, if variance of x is equals to 0, then x and y are independent. This is an obvious result. Okay, we are given that variance of x equal to 0. What does it mean? It means that the random variable x is degenerate. X is degenerated. So any associated random variable, associated, not correlated. Okay, so any associated random variable with the degenerate random variable is always independent. These imply x and y are independent. Here degenerate means the entire mass, probability mass of X is concentrated at one point C. It can also be 0, it can be 1, it can be 2, it can be 3, and so on. The whole mass is concentrated at only one point, and that point is C. This is called degenerate random variable. So we are over. The whole options are correct here. Let's move on to the next question. This question, it is given, let x1, x2, x3 and x4 following Poisson distribution, and the hypothesis is given that null hypothesis has lambda is equals to 1 and the alternative has lambda is equals to 1.5, and the critical region is given as this. So we are required to find or see the range of beta. So let's proceed. Since xi follows Poisson lambda, where I goes from 1, 2, 3, 4, then summation I goes from 1 to 4. Xi would follow Poisson 4 lambda. Okay. Now let's see the power. What is power? Power is the probability of rejecting a false null hypothesis. Rejecting a false null hypothesis. Now what is the region for rejection is summation xi greater than equal to 5 under h1. What we can write? 1 minus probability of summation xi goes from 1 to 4 xi less than equal to 4. Fine. Then we compute it. 1 minus probability. Let us denote summation xi as u equal to 0, u equal to 1, u equal to 2, u equal to 3 plus probability of u equal to 4 under h1. Fine. 1 minus e to the power minus 4 lambda, 4 lambda to the power 0, 0 factorial, and write as per the probability value. So I am writing the last one for probability of u equal to 4. Fine. So compute all of this, you will get 0.29, and after subtracting this we will get 0.71. So the range is this. So option C is correct. Now the next question is this. This is the last question of the lecture. So let's see. We are given x and y be two independent random variable having normal 0 and sigma 1 square, and y having normal 0 and sigma 2 square, where sigma 1 is greater than sigma 2. Now we have to check which of the following is or are true. This means this is a multiple select question. So let's proceed for number 1. So for checking the independence, we use covariance. Okay, this is equals to covariance of x and x minus covariance of xy plus covariance of yx minus covariance of y and y. This we can write, what is the covariance between x and x? It is variance of x minus covariance of xy plus covariance. We know by the property of covariance it is independent of its argument, so we can write covariance of xy, and this is variance of, sorry, it is y, variance of y. What is the variance of x? It is sigma 1 square, and these two get cancelled out and remained only variance of y, sigma 2 square. See, this is not equals to 0, so x plus y and x minus y are not independent. So option A is wrong. Now for number B, covariance of twice x plus y, x minus y. We can write, the constant goes out, covariance of x and x minus, the constant goes out, covariance of xy plus covariance of yx minus covariance of y and y. Now as we know, this is the variance of x, so sigma 1 square minus covariance of xy, one covariance gets deducted, minus sigma 2 square. This is equals to twice sigma 1 square. This is 0 as x and y is given to be independent, minus sigma 2 square. Now this two variable linear combination of x and y, twice x plus y and x minus y, will be independent if twice sigma 1 square is equals to sigma 2 square. Only then the covariance will be 0. So number B is correct. For number C, repeat. Okay, for number C, let's see. See, we are given that x plus y and x minus y are identically distributed. Identically distributed means they have the same distribution. So let's see the distribution of x plus y. X plus y would follow normal 0, sigma 1 square plus sigma 2 square, and x minus y will follow normal 0, sigma 1 square plus sigma 2 square. See, both the distributions are identical. Identical distributions. This means number C is also correct. Now for checking number D, repeat as number B. It is same as number B. You will also get number D is also correct. So let's end here. Goodbye. Thank you.